Now the fuzzy inference systems. What we were talking about was all fuzzy sets, fuzzy language, fuzzy variables, etc. Now we're gonna take a very precise example, which is the fuzzy inference system that will be used in a lot of systems, like control systems, like artificial intelligence, etc. We have two essential ones. There are a lot of types, but we're gonna be talking about these two, and especially the first one, which is the Mamdani FIS. The Mamdani fuzzy inference system is the most widely used approach in fuzzy logic applications due to its intuitive human-like reasoning, because it gives you a graph, and the rules are structured as an if condition then result, which is very common in our language or very common to our human-like reasoning. It has been applied in various fields, including control systems, decision making, and expert systems. Memdanifis relies on linguistic rules that follows an if something then something structure, making it easy to interpret. The key advantage of this system is its graphical representation, which visually maps fuzzy inputs to fuzzy outputs. However, its complexity increases when dealing with multiple rules and large data sets, as it requires a final defuzzification step to produce a crisp output, which will be seen later. The defuzzification is the process of taking a fuzzy variable input and making it to a crisp output. With this Mamdani option, it's gonna be very complex with a lot of rules or with a lot of membership functions, taking each one in consideration. But that's the good part about the Larson. The Larson doesn't deal with any graphs. It's just mathematical operations. But the problem with the Larson is that it's not very understandable by the humans. If you see a Larson fuzzy inference system, you're not going to catch right away the logic or the reasoning behind this system. So now moving to the steps of fuzzy inference. The first one will be the fuzzification. It is the process of converting precise numerical inputs into fuzzy values. Instead of using fixed numbers, inputs are assigned degrees of membership in different fuzzy sets. We already saw this in the example with the credit card, which is taken, for example, a credit card of 6,660 and saying that making it into a vector that tells you how much degree of membership it applies to each function. For example, it's 90% good, it's 10% neutral, and it's 0% bad. That is the fuzzification. This allows the system to handle uncertainty and gradual transitions rather than strict boundaries. The second step, rule evaluation, which is taking this fuzzy output of the fuzzification and inputting it or applying it to our rules of the if then rules to determine the possible outcome based on these fuzzy inputs. The output will be also fuzzy, but the good thing about these rules that each rule is evaluated using logical operations like and, or, and not, resulting in fuzzy output values. The final step, which is the defuzzification, which takes as an input a fuzzy value and making it into a crisp value, which is very good for that is what we want from the system, to have one output, a clear one, a crisp one that will be that we will based on our decisions. There are different methods to achieve this, such as finding the center of this fuzzy set, which is the centroid, the center of the fuzzy set, or selecting the most representative value, which is the max of mean, the mean of max. You have two like main operations, or you have two main options in order to defuzzify a given fuzzy set, a given fuzzy value. In order to defuzzify a given fuzzy values, you can either apply the centroid, which is the center of gravity, or the mean of max. Here, with an example, it will be a more clearer and easier to understand. Let's take in consideration this problem. We have this system that takes as an input two variables. The first one would be the food quality of a restaurant, and the second one would be the service quality of the same restaurant. And it will output how many percentage, the tip percentage that you should be paying based on the food quality and the service quality. In order to solve this problem, there are a lot of ways, but we're gonna see now the fuzzy inference system way in order to solve this. First of all, we should, that's the first thing. We should have a clear membership functions of what is a good, for example, good service. What is a good service? And what is an excellent service? Or what is a poor service? We should define the fuzzy sets. Each one, these three sets should be very defined, very good defined. Not just random values of random things. They all follow a certain function. Either it is a triangular or a sigmoid or trapezoidal, etc. Or it could be not continuous and it could be discontinuous. Taking the example of experts. We take a lot of experts and we ask them what is a good service for you. And experts on the field of, for example, restaurants and food, etc. What is a good service? What is an excellent one? The same thing will be done with the food quality. Once we did the membership functions, we're gonna move to writing down our rules, the essential part of all the fuzzy inference system. The rules will be based on these two outputs, and it will the two output which are the good quality, the food quality and the service quality, and it will output how high or low the tip percentage will be. The rules will follow the basic human language. This is the beautiful thing about fuzzy logic. If service is poor or food is rancid, then tip is low. It's something we as a human can understand very quickly. We don't need numbers. But for computers, this doesn't make any sense because what is poor? What is rancid? The third thing after defining the rules would be defining the membership functions of the output, which is the tip percentage. The three fuzzy sets, which are the low, average, and the high tip percentage. This will be also following a certain function. We already talked about this. Now moving in each step with a very specific example, with a very specific given example. If we give a food quality of 7 and a service of 8, then the first thing would be these are crisp values. We should convert them into fuzzy values, fuzzy variables, which is the fuzzification. Each number, each crisp value would be written or would be drawn in our membership functions. For example, 7, the food quality of 7, which is the 45% delicious, the 55% fine, and 0% rancid. But the 8% the number 8 of service quality would be 38% excellent, 15% good, and 0% poor. It doesn't sum up to 100% because it's not like linear function. It's a Gaussian function. So it doesn't always have to like be the same total number. Now moving to the inference, which are the rules. We apply the basic operations that we already talked about, the or, and not, in order to come out with the values, the fuzzy values of each membership function of the output, which are low, average, and high. For this particular example, the tip would be 0% low, and 15% average, and 45% high. So we take these outputs of the rules, which are fuzzy, and we introduce them to our graph, to our output graph, which are the three final membership functions: low, average, and high. And we fill out the surface under each percentage: 15% for average and 45% for high. Keep in mind that this particular option is the centroid or center of gravity option. There are many others. So in the center of gravity option, we fill out the surface, and we should calculate and find where the centroid is. And we take the x value of the x-axis, in the x-axis, the value of this centroid, which is, in this example, 20%. So moving in all this system, you can see that we input two crisp values and we came up with one crisp value, which with 7 food quality and 8 service quality, the output would be 20% tip. Now, if we move through every combination of the two inputs, we will get this graph. This graph is actually describing all our fuzzy inference system. With any two inputs, we get one output. For example, 0 food quality, 0 service would be 0%, or yeah, it's a 0% tip. But with 10 food quality and the 10 service quality, the tip would be 30% tip. Now this graph would be a tool for us in other systems to make them very efficient and to make them very quick in the computational time and the resources.
أخيرا وختاما أريد أن أبلغكم بشعار قناة روبوت إكس أند مور من أجل جيل هندسي مبدع. For a genius engineering generation. إلى هنا أقول لكم أعانكم الله